So, so we're looking at, today we're going to switch gears a little bit from our calculations of areas and perimeters. We're going to come back to that. We'll do more with areas and surface areas and volumes in a couple of classes. But there are a couple of little related topics that I want to make sure we cover here while we have a chance. So today we're going to talk about two of our most common measuring devices. I'm skipping over rulers and tape measures because I know you guys cover those a lot with Chris. So I'm not going to spend time on those. But I want to go quickly through calipers and micrometers. Calipers are something that you will use a lot. So as we're looking through these, the caliper, the standard dial caliper, which is what we're going to be working on mostly, we might take a brief look at a vernier caliper. Are we having sound issues at N62 or?
Yeah, I got it. We're good.
Okay, thanks. So let's look at some of the features of the dial caliper. The dial caliper actually has 4 ways that it can be used for measurement. It's standard measurement using the main jaws, which everybody is familiar with, where you place something between those main jaws and you tighten it down. Now this little button right here actually is a little wheel. It's a slip wheel that you use with your thumb to tighten it down. And when it hits the surface of the object, that wheel will slip so that you can't over tighten it and sink into the surface if you have a softer wood or a plastic or whatever material that you're measuring. And you can see it would just be you put the object in between there and tighten it down. This is way more precise than using a tape measure or ruler. The tape measure is often kind of difficult to make sure you get the ends lined up perfect, and you have to see where it lines up on the other end in the middle of the ruler. There's a lot of interference coming through here. Sorry, guys. Hopefully the system will sort it out. Anyway, the caliper it's surface to surface, so it's just a lot more precise. You don't have that slop in the reading of the measurement. Now, the other way that it can be used is to measure inside distances. These other jaws up here, when it's closed, when these two jaws are together, this jaw and this jaw line up, and as we spread these apart, they spread apart as well. So they measure inside distances, and you can see that being used there to measure an inside diameter. Those are the two types of measurements that most people are familiar with the caliper. But there are 2 other types. One is a step-up measurement. There are faces, you can see when this jaw is totally closed again, this surface here and this surface line up perfectly on a caliper. So we can use the fact that those surfaces are actually offset to measure a step up, like this. You can place it tight up against an object, and you can see this is on the upper surface, this other part's on the lower surface. You can get an exact distance in that step up. And then the final is a depth measurement. This is a depth gauge here. I've seen people actually cut that off because it sticks out, and it does kind of get in the way a little bit, but there's a purpose for it. Has the smaller tip so you can get into the really tiny holes for a little bit of depth. Then it gets bigger so that it doesn't get bent quite so easily. It can also be used as a surface step gauge like this as well. So you can see it being used there to measure the depth of a hole. So now with that, let's take a look at how we read these calipers. So this is an inch caliper, again, dial caliper. There are 2 scales that need to be read, the main scale and then the dial. And on our main scale here, there are 2 pieces of information. This is our main scale on the blade or body of our micrometer or caliper here. The 2, the bigger number, represents whole inches. Then the smaller numbers represent the tenths. Number it's pointing to, that's pointing to 15. That is 15 thousandths of an inch. So that is just put a 15 on the end of that. 2.515 inches is that measurement. So we look at this one. Whole inches would be the 5. The edge is past the 6, that's 5.6. Then on the dial we have 21, so 21. So 5.621. So do this one with me. How many whole inches? Feel free to yell it out.
3.
3 whole inches, good. How many tenths of an inch?
6.
6, good. We're past the 6 here. And then on the dial?
66.
66. So 3.666 inches is that measurement. So this one, let's do it all at once. I'll give you a second to read it and tell me what that reads out.
$4.987.
Okay, that's a very common. I'm glad you did that. But there is one little flaw. It's actually 4.887. We see the 9 sticking there, and our edge is right at the 9. We're not sure if we're just past the 9 or just getting to the 9. So we have to look at the dial. And we see that the dial is not quite back to 0 yet, which tells us we have not quite made it to the next line yet, which means the 8 is the furthest we've been. So it's 4.8, and then we add the 87 off of the dial. So 4.887 inches is that measurement. This one has a similar issue. Go ahead and read that one for me. How many whole inches?
0.
0. How many tenths? Be careful with this one.
2.
2.
2. Perfect. Yeah, we see the 3 there, but we can see that we're not quite back to 0 yet, so we're not quite to the 3. Then on the dial?
71.
71.
71. Good. So 0.271 inches is what that reads. Now we can have other styles of calipers. This is still reading inches. You can see it still says 0.01 inches there. But the difference is where it lines up. These up here, these lined up right on the edge of the jaw here. This one's a little different. If we close the jaw down tight, what lines up with the 0 is not the edge of the jaw. It's actually this little notch down here. So we read our main scale at that notch. So again, this would be 0 whole inches. We're past the 5 and not quite to the 6. I think this is a little bit easier to read the tenths with these because you can see the edge, a little bit past the edge. It's got that corner on it, which makes it easier for me at least. Then in the dial we have 63. So 0.663 inches is what that reads. What's this
Shouldn't
one?
it be 5?
0.563. Thank you. Yes, we're not to the 6 yet. 0.5. Thanks. How about this one? What's the rest of it?
8, 1, and 4.
Perfect. This is past the 8 because the dial has just passed 0. That is 8, and then it's 14 on the dial, so 814. So 0.814 inches or 814 thousandths of an inch. How about this one?
1.046.
1.046. Perfect. This one?
1.261.
1.261 inches. Good. Now I'm going to show you a type of caliper that really is kind of unique to woodworking and cabinetry. This is a 64th of an inch caliper. This can be read in a couple of different ways. You can see on the main scale here, this is actually divided into 16 units between 0 and 1. So each of those lines is a 16th of an inch. So you could, if you only need to go to a 16th of an inch, you could just read wherever that notch is and read that off. Like this is saying 1 and 2/16. So it's between 2 and 3/16 there. But the purpose of using a caliper is to get more precise than that. This one goes to the 64th of an inch. So if we're going to use the dial, all we need off the main scale is the whole inches. That's 1 whole inch. Then on the dial, we have to figure out how many 64ths that is. To do that, what I usually do is I pick one of the labeled marks that's close to the dial. So I'll use this one, the 1/8. And I convert it to 64ths. 1/8 is how many 64ths?
8 64.
Good. Yeah, 8 times 8 is 64, so 1 times 8 is 8. So that is 8 64ths. So this is 9, 10, 11 64ths. Which is that needle closest to, the 10 or the 11?
10.
It's really close, isn't it? It's hard to say. I guess I can't argue either way. I was thinking it might be slightly closer to 11, but it looks like it's really right in between. So 10 64ths. Now that can be reduced. Both of them can be divided by 2. Give me 5 30-seconds. So that is 1 and 5 30-seconds of an inch. Okay, so on this one, we have 0 whole inches. The 1 inch mark is back in here somewhere. So to get the 64ths, half an inch is how many 64ths? Half an inch is how many 64ths?
32.
32 64ths. Good. So that's 32. This is 33, 34, 35. Which are we closer to, the 34 or the 35? That's another tough one. It looks like we're pretty close to right in the middle. I'd maybe say slightly closer to the 34. So 34 64ths, of course that reduces by 2 to give us 17 30-seconds of an inch. In your notes, read this one, write it down, and I'll go over it in a second. So this is 1 whole inch. 5/16 would be 20 64ths. 21, 22, it is dead on 22 64ths, which reduces to 11 30-seconds. So 1 and 11 30-seconds of an inch. Now you probably won't see one of these in your career. It's still used in certain places. Like I said, cabinet shops that measure to 64th of an inch. I know actually several years ago, Mastercraft there in Rice Lake switched over from doing all their tolerances to a 64th of an inch to doing them to a 100th of an inch, just so they can get rid of this type of caliper in their measurement. So here's a metric caliper. In the metric caliper, the main scale, these are centimeters. That's 1 centimeter, 2 centimeters, and 3 centimeters, and so on. The problem is, if you look at the dial, that's 0.01 millimeters. The dial's in millimeters, and the main scale is in centimeters. So to make them work together, we read this not as 1 centimeter, but as 10 millimeters, which is equivalent. So that allows us then, that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 millimeters, and so on. So this one, we're right at that 3, which would be the 30 millimeter mark, but we see our needle is past 0, so we have passed the 30 millimeters. That's 30 millimeters. Point, the dial gives us our first 2 decimal places, or the hundredths of a millimeter. That's pointing at 31. Did not want it to blow up quite that fast. So this is 30.31 millimeters. So for this one, that's 20, 1, 2, 3. Not quite to the 4 yet, because we're not quite back to 0. 0.96 off the dial, so 23.96 millimeters. So on this one, what do we read off the main scale?
$50.
50,
2,
52, good. What do we read off the dial?
41,
41, so 52.41 millimeters. How about this one? What's the whole reading? So that lines up, the little notch is lining up with 17 there. That's 10, 11, 12, 13, 14, 15, 16, 17. And the dial is 77. So 17.77. That's millimeters. Again, read this one in your notes. We'll go over it in a second. So we're right on the 9 there. The needle has just passed 0, which means we've actually just passed the 9. So that's 9 whole millimeters. And that's 12, so 9.12 millimeters. We'll have you do one more in your notes, and then we'll... So our main scale here, that's 62.48 off of the dial, 62.48 millimeters. Now the struggle that a lot of people have with the calipers is keeping the decimal point in the right place. Especially when we jump from metric to standard. I'm going to jump back up to standard here quick. And have you read that one in your notes quick. Now remember here, the metric is actually in the middle of the 2 numbers you get off the main scale. This is 4 whole inches and 4/10. That's 4.4. And then off the dial we have 43. So 4.443 inches. This one, I'll give you a second to read it. .142 inches. This one, I'll give you a second to read it. But we have moved it back to millimeters here. So this is 27.60 millimeters. This one?
Oh.
I'll give you a second to read it again. So this one is just past the 28 because we've just passed 0. 28.28 millimeters. How about this one? Well, this one is switched back to inches. This is 1 whole inch. We're not quite to the 9 because we're not quite back to 0. So this is 1.8. And that's 96 inches. Give you a shot at this one.
Mm.
So 2.1, 37, so 2.137 inches. Take a stab at this one. This is millimeters, so that's 22.37 millimeters. So as I said, the big issue is making sure you keep the decimal point in the right place. Let's take a look at micrometers. Micrometers have several parts and several different levels of reading that they need to use. Oh, no. Unfortunately, I didn't bring any micrometers home with me, so I can't hold one up so you can see it. But a micrometer actually looks kind of like a C-clamp. You've got the big C, and then you've got what we're looking at here on the PowerPoint slide. Sits down at the bottom of the C, and it spins. The barrel is attached to that C-shaped portion. So it'd be something like this here. Actually, not quite like that. It's something like this. So the rod comes out there, and then there's a foot over here that it hits up against. So the object you're measuring goes in between those two. So that barrel is attached to it, stays stationary. The thimble spins around it. Now there are threads on this thimble. They are threaded at, I don't remember exactly what it is now. Each spin is 25 thousandths of an inch. So you see on the main scale, we've got 1, 2, 3. Those are not whole inches. Those are tenths. That is signaling 0.1 inch. The marks in between them are what are referred to as quarter marks. This is 0.125. That's 0.150. That's 0.175. And this is 0.2. Or 0.200, we should really call it. Then the thimble is the part that spins. That has the rest of the number, the 25 thousandths that we need to add to that piece. Let's look at some examples here, make it a little bit easier to actually read them. So when we look at this, on the barrel, that's 2/10. That's 0.2. We're past the first quarter mark. We're not quite to the second quarter mark yet, so that's 0.225. Then on the barrel, what lines up with the axis, on the thimble, what lines up with the axis of the barrel is the 15. So that's 15 thousandths that we're going to add to that. 0.225 plus 15 thousandths is 0.240 inches. So for this one, that's 0.4 Are we to that first quarter mark?
Yep.
We are actually exactly on it because the 0 is lining up with the axis there. That's 0.425, and that's it. We are exactly at that quarter mark. So for this one, are we to the 0.8 yet?
Yeah.
I'd say yes.
Just like the last one, we're on the 0 on the thimble is exactly lined up with our axis here, which means we are exactly on whatever line we are close to. Well, we are close to that 8/10. So this is actually exactly 0.800 inches. This one we have 9/10, so that's 0.9, 25, 50, 75, so 0.975. And then what lines up on the thimble?
5.
5. So that's another 5 thousandths that we add to that. So that's 0.980 inches. So how about this one? How many tenths?
0.5.
0.5. How about quarter marks?
7.5.
7.5. So 0.575. 25, 50, 75. On the thimble, what's it reading? That's 20, 1, 2, 3,
28.
24. So that adds up to 0.599 inches. There are two ways that we can tell that this is an inch micrometer. One is that those are labeled by ones on the barrel, and we have the quarter marks between them. And the thimble goes from 0 to 20, and then at 25, it turns back to 0 again. So it basically goes from 0 to 24 is what our thimble goes to. When we hit our metric, that changes slightly. That's still standard. Let's read these first. This is an inside micrometer, or a depth gauge micrometer, basically. Our standard micrometers only have 1 inch of travel. They go from 0 to 1 inch. The reason for that is because the 250, what is it? No, it's 20. It's 100 threads per inch. You'd have to turn it 100 times to advance 1 inch. Well, if you've got like a 6-inch range, you're doing 600 revolutions to move the whole thing. That's a lot of twisting. It really wouldn't work well. It wouldn't be very efficient, and the machining to get that many threads that precise would be a tremendous feat to do in the machining. So what they do is, if you need to measure something larger than an inch, they actually have micrometers that go from 1 inch to 2 inch, which means their jaws don't completely close. If the jaw is completely closed, it would be there. There'd be still a 1 inch gap here. Then there's the 2 inch to 3 inch. So then that would be a 2 inch gap, and it would close to open up to make it a full 3 inch gap. It would be the widest it can measure. Well, for these depth gauges, rather than having different actual micrometers, they have different extensions. This is a 3 to 4 inch extension, which is telling us that this measurement starts out at 3 full inches. Then we read the barrel. What's the barrel read on this one?
$2.25.
Not 2.25, but 0.225. Remember, these are still tenths. That's 0.1, 0.2, and then we're past the first quarter. And then, of course, the thimble reads 20 thousandths more. So this is 3.245 inches is what that's reading. Now I want you to look closely at this one, and now look at this one. They both have a 3 to 4 inch extension on them. But what's different between the two of them? What's different on this one? There's that extra little piece. That's a 1/2 inch extension. The threading on these inside or depth micrometers only goes up to a 1/2 inch rather than a full inch. So we use those 1/2 inch extensions to get anything over 3.5 inches. So this is 3.5 inches is where that's starting out. So 3.50. Then on our main scale, this is 0.325. What is it reading on the thimble there? Well, this
12.
main end is lining up with the 12. Good. So that adds up 3.837 inches. So there's a few more pieces that we have to look for on these inside or depth micrometers. So this one here, we have a 2-inch extension. Do we have an additional 1/2 inch extension?
Nope.
Nope. So we're just 2 inches is where we start. What are we reading on the barrel here?
0.350.
350. You got it. 0.350. And on the thimble?
.024.
0.024. Good. So we've got 573, 2.374 inches. Well, let's look at the millimeter micrometer. We can tell the difference between the millimeter and the inch. As we said, the inch is labeled in ones, numbered in ones as we go up through here. This is numbered in fives. So 0, 5, 10, 15, 20. On the thimble, the inch one went from 0 to 20, technically 0 to 24, and then wrapped to 0. This goes from 0 to 45. Technically, it's from 0 to 49, and then it wraps to 0. So as we read this, the thimble, or not the thimble, the barrel here is the whole millimeters. In fact, these lines here are actually half lines. This is 15, 15 and a half, 16, 16 and a half, 17, 17 and a half, 18, 18 and a half, 19, 19 and a half, 20. So this is 20 and a half. Are we past the 21 line there? Yeah, we have
I'll
just
say yeah.
passed 0. So we just passed the 21. So then what on the thimble lines up with our axis?
4. Nope, 5.
5, right on the 5. Now that is hundredths of a millimeter, so that is 0.5. 21.05 millimeters. So for this one, this is 15, 16, 17, 18.5. Now as I look at that, we're definitely past that line. So this is 18.5. We're almost to the next line because what lines up on our thimble is
45.
45. So we have 18.5, and then we add the 45 to that, gives us 18.95 millimeters. This one here, this is 5, so 6, 7, 8. Are we to the 9 yet?
I'll say yep.
Right at it.
0 lines up with our axis. We are exactly on the 9. This is 9.00 millimeters. Now, as we talked about at the beginning of this unit, do we need those 2 zeros there?
No.
Mathematically, we don't,
Yeah.
but for measurement, we do. To let people know that we did measure this to the 100th of a millimeter. So as far as the measurement is concerned, we do need to keep those in there so that people know that we did go down to a precision of the nearest 100th of a millimeter. So let's read this one. Somebody tell me what you got for it. Again, the reason I'm jumping back and forth is a lot of people screw up the decimal points. A lot of people would want to say 6.25. That's not correct. Remember, this is inches, so this is 0.625. The thimble then is reading 1, so that's 0.001, giving us 0.626 inches. This one here, I'll give you a second to read it, and then we'll go over it. Excuse me. This is 0.425. Then the thimble is reading 9, so 0.009. That is 0.434 inches. This one is back to millimeters. 10, 11, 12, 13, 14. We are just past 0, so we just passed the 14. And what lines up here is 3. That is 0.03, so that's 14.03 millimeters. Try this one in your notes. We're at 15, 16, 17, 17 and a half. Question is did we make it to the 18? And the answer is, of course, no. We're at 35 here. We're not quite back to 50, which means we're not quite to that next line. That is only 17.50, 17 and a half. And then that's 35 there. Since this is millimeters, that's 0.35. That is 17.85 millimeters. Back to this one. Again, we have to make sure our decimal point's in the appropriate spot. This is inches. That is 0.325. 0.3 and this is the quarter mark. And then that lines up with 13 there. So we add 13 to that. That is 0.338 inches. Good question.
Recording is on.
So in Blackboard, there is a packet that is put out there for today. In that packet, I have two versions of it. There's a Word version and there's a PDF version. It says worksheet, more calipers and micrometers. That'll allow you to practice your calipers and micrometers. There's another one out there with just calipers on it if you'd like to practice with those. Those are actually, most of them are the ones that are in the PowerPoint, so we've done all those. But if you want to go back and redo them, you can. So that is your homework for tomorrow. We got about 10 minutes left. So I'll let you use those 10 minutes to get started on that. I'll be